So I'm assuming this is that same problem that you sent me at first, and I guess you worked on the board. I just swapped x and y on each one of them just to see if they were inverses, but I guess you could use composition of functions, f of g of x and g of f of x. So I'll try and show you using that one this time. If we do f of g of x, we're going to plug in. So f of x is going to be -3 on top, and then +1 is over here. And instead of x, I'm going to plug in the second equation. Okay, so I'm going to plug in -3 over x minus 1 minus 1. And then I still got my +1 on the bottom from the original equation. Super duper complicated looking, okay? But what happens is the ones, they cancel out, okay? And you get this fraction, okay? And so if you divide by a fraction, it's the same as multiplying by the reciprocal. So this is really like -3 times x minus 1 over -3. I just flipped it. And then those two cancel out and give you 1. Okay, so you're just left with x minus 1 plus 1, which gives you x. Okay, so you got f of g of x, and it gave you x. So that's cool. Okay, the other way is to do the other equation, so that we can do g of f of x. And if you do that, you take the problem. So we had -3, and then the -1 part. And then at the bottom, instead of x, you're going to plug in that first equation. Okay, so you're going to plug in -3 over x plus 1 plus 1. Okay, and then you still got your -1 from the bottom of this original equation. Okay, so +1, -1, they cancel each other out. When you divide by a fraction, you're going to flip and multiply. So this is going to be like -3 times x plus 1 over -3. The -3's cancel, and you're left with x plus 1. You still have your -1. Those cancel, and you're left with g of f of x equals just x, which tells you, yes, they're inverses. Okay, so that's the other way that you could do inverses. It's a lot of manipulation either way it goes, but just let me know if that helps.